All right, this is Mr. Wyrick, and today I'm going to go over part of the notes for 3.7, intersections of circles and lines. We're going to actually do this across a couple of days. So you're going to need to do part of it and then come back and finish it because it's way too much to do on just one single day. So this is actually going to start tomorrow on the 3rd. But don't forget, we're doing the review Monday, the test Tuesday. So then we'll pick this back up on Wednesday, the 8th. Some of you will have me in class. Some of you will have video kind of going over it because that's when we leave for College Station. So intersections of circles and lines. That's the first slide there. The second slide talks about the equations of circles. Now we did equations of circles yesterday. It's x minus h squared plus y minus k squared is equal to r squared. There's probably still some stuff on the board around about like how that works with the center of the circle and whatever. A couple of these are going to have that written in, so it's going to be a little bit easier for you. But remember, it's talking about using a right triangle to find the distance from the center of the circle to any point on the circle in a direct line. So that's the radius of the circle. Okay. So the next slide talks about equations of lines, and linear equations should be y is equal to mx plus b, where m is the slope of that line. Hopefully we can clear up some of the issues we were having with being able to do positive slopes or negative slopes and figure out what's going on there. And b, of course, is going to be the y-intercept there. So that's slides 1, 2, and 3. Just remembering how to write equations of circles, remembering how to write equations of lines. And then your day 1 assignment. We're going to get partially started on this, okay? This should be a PDF for you to edit so you can kind of put the stuff together. So I'm going to slide over here and click onto that. Here we are, my 3.7 paper. So I'm looking at number 1, and number 1 is one that has them labeled. So I'm going to show you kind of what to do here. So I have my first equation, and that is y is equal to, let's see, where is it? X minus 7. Okay, that's my linear equation. So I can see what's going on there. And then my circular equation, my equation of my circle is x minus 5 squared plus, let's see, y plus 7 squared is equal to 25. So we have to look at kind of what information we have here. So the x minus 5 means my center point is over 1, 2, 3, 4, 5. And then the y plus 7 means it's down 1, 2, 3, 4, 5, 6, 7. So I have a center of my circle here, and my radius is the square root of this number over here. So this is 25, so my radius is 5. So it's actually going to come straight sideways and touch over here at this -7 and kind of come around like this. Y is equal to x minus 7 means we're going to go through right there. And we have 2 intersection points. So we're going to find those eventually. What I would like you to do today is this. I know exactly what y equals. Y is equal to x minus 7. So I'm going to take this x minus 7 and I'm going to put it into this equation for y. So I have x minus 5 squared plus, instead of the y, I put x minus 7. I don't lose my plus 7. I don't lose my squared. And that equals 25. Okay? So I have x minus 5 squared plus x, because a -7 plus 7 is going to make 0. So that's x squared is equal to 25. Okay? And again, we'll kind of go through the algebra after I come back. But for now, like, this is what I want you to do is take whatever equation you're given, substitute it into the circle equation from the linear equation, and then kind of put those together and see if you can get it to start working out. Okay? You don't need to go further than that because we're probably going to have to talk a little bit about going back to like the box method and multiplying binomials together. And we're going to have to talk about factoring a little bit in order to get our X answers. But this much you should be able to do on your own, and then we can pick this up on the other side of the test.